Unlike the previous problem called feeling lucky, where we wanted to modify the search engine such that it returned the highest ranking result, we want to create a new function that orders the results according to the ranking. Now in order to do this, what we need to solve is sorting. We need to be able to sort the pages according to the ranking. This is a very well-studied problem and a canonical example of algorithms. For the purposes of this course and the kind of reinforced recursion, we're going to use the Quicksort algorithm. Quicksort is interesting because it's incredibly elegant, it's recursive, and it happens to be one of the fastest ways you can do sorting. And we're going to do it in just a few lines of code. Before we get started, I'll go quickly over how Quicksort works. Let's say we have this list of 5 elements, and we're going to go through the Quicksort algorithm. The first thing we need to do is to choose a pivot point. A lot of implementations use a random one, but it really doesn't matter if we assume that the data we're given is randomly distributed. So let's just choose the first element as our pivot point. That makes coding it simpler, and it's also a little simpler to go through. What we're going to do now is divide the rest of the elements according to things that are smaller than the pivot point and things that are greater than the pivot point. So let's do that. So we have our pivot point 2, and now we're going to go through the rest of the elements and decide whether or not they're greater than or less than 2. A pretty simple operation. So 1 is less than 2. We're going to add it to this list. 8 is greater than 2. 0 is less than 2. Notice how I didn't bother with the ordering of the sublist. We're going to take care of that by recurring Quicksort onto the sublist of each side. 9 is greater than 2, and we're done. What we have is kind of a partially sorted list. Everything that is less than 2 is on the left side of this. Everything that's greater than 2 is on the right side. So what we're going to do is we're going to redo the same thing to the left side, the same thing to the right side, and in the end, once we sorted everything, we combine them all together, and we have a sorted list. So let's go through that real quick. So here, 1 is the pivot point. We get 1. 0 is less than 1. Here, 8 is the pivot point. 9 is greater than 8. And we're done here. We're also done here. And now we're left with single element lists. We do quicksort on each of these, and a list of one element is sorted, so we're done sorting at the bottom. We now append on the way up. So the end result of all these appendings will be our sorted list. And just to finish our list, let's just say we called it conquer. Hopefully this gives you an idea of what we're doing. So let's go to the code, and it might become a little clearer if you're confused. So our ordered search takes in 3 parameters: the index, the ranking of the pages, and the keyword that we're searching for. I'm going to look up the pages that are associated with that keyword, and then we want to quicksort the pages according to the rankings that was passed in to ordered search. This is another function that we'll have to define. So I'm taking in 2 lists, the URLs, and the rankings of those URLs, which is stored as a dictionary. So if I didn't get any pages passed in, or it was an empty list or whatnot, then I'm just going to not do anything and stop right here. This saves some cases that add a little bit of complexity later on if we take care of it now. So the first thing I'm going to do is find the pivot point, which is the ranking of the first page. That's basically how we did it in the example I went through. We initialize our 2 lists, the better list and the worst list, and now we're going to go through each page and put them in the correct list accordingly. One thing you might notice that I didn't go through every page. I skipped the first page. That makes the code a little bit simpler because I've already included the page as the pivot point. Once we put the pages in the correct list, we're going to recur. In order to get the list concatenation to work appropriately, you need to put this pages into another list. And this is the appending that I showed at the end, and this is the recurring that I showed earlier. And this is all Quicksort is. We got, 14 lines of code, 13 lines of code, and we could even save a little bit here and there if we wanted to, but we're just going to recur, and we're done. To go through it real quickly, if we have one page in our list, or if there are no pages in our list, then it's considered sorted and we return it right away. Otherwise, we find our pivot point, which we're going to use as the first element, and for the rest of them, we're going to put them in the appropriate worse or better list if they're better or worse ranked. We're then going to recur on each of our sublists, and once that's done, we're going to append them all together.